Welcome back to Math 103. This is video number 16 on apportionment. We've discussed Jefferson's method. Webster's method is another modified divisor method. But instead of always rounding the modified quota down, as Jefferson did, Webster's method rounds in the conventional way. That means it rounds to the nearest integer. It rounds in the way that you are accustomed to rounding. So the goal is for the rounded modified quotas to sum to exactly the correct number of seats. Let's see how this works in some examples. So recall our very first example of an apportionment problem from the very start of this chapter. We had these 6 states and their populations, and in the original version of this example, 25 seats. So we computed the standard quotas, and now let's look what happens if we just round these in the ordinary way. Each standard quota rounded to the nearest integer. Great, so 11.33 seats rounds down to 11, 6.12 seats rounds down to 6, 2.52 rounds up to 3, 2.16 rounds down to 2, 1.8 rounds up to 2, and 1.08 rounds down to 1. It's very important when you read this number that you read it as 1.08. If you made the mistake of reading this as 1.8, people would think you meant that number instead. All right. And note that 2.52 is rounding up to 3. The cutoff for rounding up versus down is 2.5. Okay, so if this were equal to 2.5, we would still round up, and anything greater than 2.5, we certainly round up to 3. All right, so that's conventional rounding, and when we add up these rounded standard quotas, as luck would have it, they add up to 25 seats. So fantastic, that worked out very nicely, and we could have asked then, in fact we did wonder then, why couldn't we just do this all the time? Why do we need a fancy bunch of apportionment methods? Just round in the obvious way. Well, we got lucky. The fact is, it doesn't always add up to the correct number of seats. When it does, then what we've just obtained here is indeed the Webster apportionment. All right, so when the standard quotas, rounded conventionally, add up to the correct number of seats, we're done, we don't need to do anything more. But what happens if we don't obtain the correct number of seats? For example, let's see what happens if we have only 21 seats to apportion in this very same example. Well, when we compute the new standard quotas, we have no choice but to just go back to the drawing board and recompute all the standard quotas. So you can check this if you don't believe me, but 13.9 million divided by 21 seats gives us a new standard divisor. We proceed from there. If you believe me that these are the standard quotas, then how do these round to the nearest integer? Well, Massachusetts rounds up to 10, Connecticut down to 5, Maine down to 2, New Hampshire up to 2, Rhode Island up to 2, and Vermont up to 1. And when we sum these up, they add up to 22, and that is bad news, right? That is not the correct number of seats, and so we need to do something else. Webster's method requires us to select just the right modified divisor. There will be a whole range of possible ones, but we need to find a modified divisor so that the rounded modified quotas sum to the correct number of seats, where the rounding is done to the nearest integer in the conventional way. Now in this example, which had 21 seats, but the standard quotas, after we rounded them, added up to 22 seats, should we use a modified divisor less than or greater than the standard divisor? Think about that before going on to the next video.